or puzzle pieces in Scratch. So let's round out a few more. So in C, it's actually not all that easy to get user inputs. You kind of have to jump through some hoops just to see what the user typed, and not to mention convert what they've typed from ASCII characters to actually numbers. For instance, when you type in 1.5 on a keyboard, that's not a number. That's actually the character 1, the character period, the character 5. So you have to kind of convert that to a floating point value. And how we do that we'll ignore for now, but suffice it to say some work has to go in to getting user input. So we have what's called the CS50 library, which is a suite of functions that you can use in your programs, and indeed we do for the first several weeks, and the names imply what they do. If you want to get a character from the user, we're going to call get char, or get double, or get float, or get int, or get long, or get string, depending on the data type, and that's going to allow me to write programs like this. Let me go back to my code here. Let me go ahead and say not just oh hi world now, but let me declare a variable. And in C, you declare a variable like this, string s. And I'm going to go ahead and say get a string from a user. And getString, just like printf, is a function. But what's neat about getString is that it doesn't just do something and leave it at that. It does something, and then it hands it back to me. All right, so it's as though this is doing my bidding. GetString, it's going to deal with all the complexity of keyboard input. It's going to get that string of characters from the user, and it's going to hand it to me in such a way that I can store it inside a variable, just like Scratch. And I'm going to call it s. And the type of that variable is what we'll call a string. If you're familiar with Java, it's not capital S, it's lowercase s string, but it's just a variable. And that's because of the CS50 library. Now, again, I said that we don't always have to type oh hi world. We can pass in an argument whose value changes. So it turns out in C there is these placeholders. And if I do not just a hard-coded string of characters, I do %s. That means put a string here. Well, what string do you want to put there? Well, let me go ahead and just move outside of the quotes, comma s. And what we'll see here is that some functions can actually take not just 0, not just 1, but even 2 arguments. And the convention in programming is to separate those arguments, those inputs, those parameters, again, all synonyms, by a comma-separated list of arguments. So now what's going to happen? Well, whatever I typed is going to get printed, and that is going to be because the s gets substituted for the %s here. But I need to do one more thing, and I can finally now explain what was going on here. This include standard.io.h is what's called a header file. It turns out that I can't just start using things like printf and just assume that they'll work. I have to tell the compiler, I want to use a function called printf written by someone some 20, 30 years ago, and that function is declared. It's written in a file called standard.io.h. Now, I don't know where that is. It's somewhere on the hard drive. But the compiler knows where to look by default. So that's why I was able to use printf. If I had omitted the highlighted first line, I would have gotten some kind of error. Same thing with the CS50 library. If I want to use the CS50 library, I have to say use CS50.h. And I don't know where this file is. It's somewhere in the appliance's hard drive. GCC will find it for me. But now I have the ability to use the getString function as well. So you didn't have to do this in Scratch. Scratch makes everything available to you at once. But now I have to be a little more deliberate. And that's OK. It keeps my programs even more explicit as to what's going on. So let me zoom in again. Let me type, what do I type to compile this? Yeah, it's kind of there, right? You can always cheat there. So make hello, enter. OK, no errors, so that's good. Run hello. Nothing seems to be happening, but I do have a blinking prompt, so I can say something like David, enter, and kind of a bug. I don't really like that output. What can I do to fix? Yeah, \n there. And I can make this a little more user-friendly. I can say something like printf name please :space. And again, a semicolon. Turns out this is just a convention. At the end of most any statement in C, you have to put a semicolon. So now I have a 3-line program. Let me go back here and rerun it. David, didn't fix. OK, good. Right, so just because I changed the source code doesn't mean the program itself is going to start working. So let me actually rerun make hello. That looks good. Now let me rerun hello, enter, name please. That looks prettier. Enter, David. Now you can imagine making even more sentence structure there. But now we have the ability to get input and get output. But let's take a look at just one other format string. Turns out I'm going to go ahead and get a float from the user. And I'm going to have to change this now to float f. And the name of my variable, I'm just keeping it simple. F for float. I only have one variable. There's no confusing it with something else. I'm going to put %f here and f here, because now I want to say, just give me a number, please. So let's go ahead and run this program. So let's go ahead and run make hello. Run hello. Number, please. Let's do 1.5. Enter. Interesting. That looks pretty precise. That's a lot of zeros. But it turns out we can reveal to ourselves, at least for educational purposes here, I actually want to see what number's really being stored there. Let me go ahead and show 10 digits after the decimal point. So I'm changing the format string. Instead of just %f, I'm doing %.1f. But that's just so I'll see more on the screen. So let me rerun this. Make hello. Let me rerun hello. Enter 1.5. Interesting. So that's actually a pretty good number. Let's try something else. Let's run it with 0.1. Enter. That is not what I typed. So why did this just happen? I'm pretty sure I did not type 0.1000015. Why does the computer think that's what I indeed stored in the variable? Yeah?
It doesn't have enough precision to represent 0.1 exactly.
Exactly. It doesn't have enough precision to represent that number, 0.1, simple as that number is exactly, because if you only have 32 bits, you got to pick and choose which numbers you will be allowed to represent, so it rounded to the closest possible match. Now, this might seem like a silly bug or issue, but it can actually lead to very serious problems. And indeed, to help visualize this, there's some very famous examples in history of programs and real-world things that have been implemented in software, and that software is flawed because humans like us literally have made mistakes as simple or as trivial or as innocent as that. And you'll see from this video some of the things, both with real consequences or not, that tend to happen. So let me go ahead and pull this up. It's it to say there's all sorts of non-militaristic applications of this stuff, but it's frightening just what the implications are. And so over the next few weeks, what we will do is focus not only on doing, but on understanding exactly how all of this stuff works, so that you yourselves are empowered to build most anything you would like by term's end. We will see you on Friday.